Okay, slope is determining the rise over the run, or the vertical over the horizontal. So we're going to type that definition in there. The slope of the line is the vertical change over the horizontal change. So let's put that into what makes sense. Vertical is up and down. Horizontal is back and forth. So if I were doing this activity, it would be something as simple as counting each corner. So the vertical, the up and down, the rise is 1, 2, 3, 4, 5, 6. So I'm going to change this. That would be 6. You can't change it. That's what it is. The horizontal would be 1 to corner, 2 to corner, 3 to corner, 4 to corner, 5 to corner, 6 to corner, 7 to corner, 8 to corner, 9 to corner, 10 to corner. So this one would be 6 over 10. I believe what it wants you to write over here is you're going to put rise, and I might put up and down, make it fit, over run, which is right to left, or back and forth. In the case of this one that we just calculated, it was 6 was our rise, 10 was our run. And if we were to reduce this, these are both divisible by 3. No, by 2. Sorry, divisible by 2. So this would end up being 3 over 5. So the rise over run for this one will be 3 over 5. So at this point, that's as far as we've gotten in terms of the definition. We're going to continue on and go to the next slide. You have some little lines here that you get to drive, and we're going to do positive slope. The positive slope will go up from left to right. And drag one of these, and then make sure that you angle it. Well, that's not how you angle it. You angle it so that it goes up from left to right. So it looks like that skier or skateboarder or whatever is going up and down. Negative slope will move down from left to right. You're going to pull the same thing here. You're going to find where the little angle thing is and move it so that it looks like it's going downhill. An undefined slope has no movement. That's what I'm going to call it. Up or down. It is a vertical. Nope, it is a horizontal line. And let's draw one of those. That means that it looks like, let's get it straight, that. There you go. Zero slope is a horizontal line, nope, vertical line, straight up and down. And so you will pull this last one so that it's straight up and down. Okay. This one is when we start trying to count and figure out what the actual numbers are. Let me delete what I did before. I'm going to make sure I get a better color so that you guys can read it. We need to figure out what the up and down change is first. So in this case, I'm moving down. So I'm counting squares. 1, 2, 3, 4, 5, 6, 7. Oh, went too many. Okay, so let's go back and figure out how many that was. 1, 2, 3, 4, 5, 6. Okay, so I got to 6 for my vertical, my rise, but it was traveling downward, so I have to make sure that it's negative. Now, if I were to move across my run, 1, 2, and it's moving the same way as positives on a number line would be, so it's -6 over +2, which that would be 3 over 2, because I can reduce. Divided by 2, divided by 2, and notice Miss Beacon made an error, so it's 3 over 1. What you will type is 3 over 1. So right here, 3, I raised 3, and I ran 1. And we can verify our answer to make sure that that reducing works, because the theory is if I, let's see, up 3, 1, 2, 3, back 1. So I just realized I didn't make one of those negative. So I need to make sure that I have a negative number. But yes, this does work. Let me go in here and fix this. It's -3. Okay, so now we're going to determine the slope on this one. We're going to make our little stair steps. I'll get a color that hopefully we can see. So I see another place where it crosses the line right here. You see how it crosses at the corner? I'm putting a dot there. So I'm going to rise 1, 2, +2. I'm going to run 1, 2, 3, +3. Let's see if it works a second time. Rise 1, 2. So it's a +2. Run 1, 2, 3. So what we will type is the vertical change here is 2. The horizontal change here is 3. So our slope is 2 over 3. Okay. We're moving on to the next one. Find the slope. Well, this one goes straight up and down. So if I go to my original definition, straight up and down has a 0 slope. So I'm going to come back down here and I'm going to type 0. This one I have to figure out. So I'm going to count my rise over my run. So there's a dot, there's a dot. So I rise 2, that's +2, but I'm going backwards 1, 2 as well. So that's -2. So the rise of a run will be -2 over 2. I can reduce by dividing the top by 2 and the bottom by 2, and I end up getting -1 over 1. You cannot just type -1 because you need to know what to rise and what to run. -1 over 1. All right, couple more. A little bit more practice right here. Going to practice with our rise over run again. So this one I'm going to rise 1. So that's up 1, to the right 1, 2, 3, +3. So my rise over run, my slope, is 1 over 3. So your text answer will be 1 over 3. This one is a back and forth, so I can't make any stair steps. It has 0 slope. Oops, pushed the wrong button. Go to the next one. Oh, this will be interesting. Draw a line with a given slope. So for me to do this, I want to go ahead and plot some points. I'm just going to pick some random point on the place. I'll pick this one, if my computer will let me. Pick that point. This 1 tells me how far to go up or down. It is positive, so I just go up 1, okay? And the 4 tells me to go back and forth 4. So 1, 1, 2, 3, 4. There's another point. If I were going to continue, I would rise 1, and then run 1, 2, 3, 4. So my next point would be about right there. Same thing. So I'm going to drag you got to get this, pull it over, and it erased all of my lines, but hopefully you guys can check it. So 1 over 4, I think I picked the spot right here. So that's, oh, I got to move him down a little. It's a little hard. So looking carefully, if I check it, let me see if I can do this a different way. Maybe my points will stay there if I do that. Here. Let's put my points. I picked a point right here, and then up 1 over 4. See, it's not quite right. Up 1 over 4. So that means I have to grab this and kind of make sure that I'm as close as I can to where it's supposed to be. This is easier to do on paper than it is on the computer, but it's what we've got right now. So, undefined, oh, I guess you can drag your points to help you. Maybe I should have done that. Undefined slope makes a cliff, so you just drag that anywhere. It's straight up and down. So, what I should have done for this is dragged these 2 points here, but I did not know that. There's one, and there's my other one, and then my line has to kind of show that it's going through those. I don't know if I have another one behind this or not. Let's see. Yes, we do. So let's try it the right way. This one was a slope of 0. Well, slope of 0 is just a straight line like so. So he's easy. He didn't go anywhere. Slope of -2, 3. I'm going to pick a random point, and then I'm going to count down 2. So 1, 2, because it's -2, and then over 3. 1, 2, 3. So my next point goes right about there, and I bring my arrow that I'm drawing, and I hopefully get it through those 2 points. Yes, when you're graphing on a computer, it's not going to be able to be perfect, but the 2 points show me that you understand how to do rise over run. So that is how you do rise over run. It's counting and making stair steps. If you are in class, you'll be coming back and doing it on paper with me. Those of you at school, I would suggest, or at home, I would suggest making sure that you're using your marker on your dry erase marker on your computer and kind of checking those lines to make sure that you've got it right, because you will be responsible for calculating these.